go.
The board's frozen still, huh? All right, axis of symmetry. Let's see what you guys came up with. Still frozen. There we go. Axis of symmetry. What formula did you come up with from your 8-3 notes? Raise a hand and Josh, go.
Negative b over 2a.
Stop eating. Okay. What equals negative b over 2a? Ian.
That's why I was asking Diego, because I don't understand this part.
Pause. Let me see your notes real quick and I'll help out. Okay. Angel, you were reading your notes really well.
Yeah.
What equals negative b over 2a?
X.
Okay.
X equals negative b over 2a.
Beginning of your 8-3 notes. What did I tell you to write down from axis of symmetry at the beginning of your 8-3 notes? So did you write that down? Okay. What do you need to explain in Spanish about that? Okay, so
Yes, we take it in there.
did you write that down?
Yeah, exactly. Take that tail stuff.
Did you write that one?
Yeah, this video, man.
Ian.
J. That watch is bigger than you, though.
Who watches that?
So from the beginning of 8-3, write down each of these formulas.
Who watches that?
So x equals negative b all over 2a.
Girls.
You guys
So
see
you
how
have to
opposite?
put x equals?
Yeah, sure.
No.
I know.
You try writing at the bottom now, maybe it goes to.
Which way is it? Can you try one more time? See how bad it is?
Oh, I remember I had to do this.
Maybe we should just do it on the board. The normal board.
Wait, what does that do?
Wait, what?
It evens it out.
Calibrates it. Let's see if it actually works. Just one of those things that's supposed to work better, but my smart board, I think it's just kind of wonky right now. We'll see how long it lasts.
It's
Okay.
only the last one.
Vertex. What are you supposed to write down for the formula for vertex? Rob.
X and Y.
Mm-hmm. X and Y. How are we going to get this x?
You multiply.
By multiplying the answer to the axis.
No.
Or
how
no,
are we
no,
gonna
no.
get the
I'm
x?
plugging it in.
By plugging it in.
Yeah, that's what I meant.
So we could theoretically, if we wanted to give ourselves a way of remembering, we could go ahead and put negative b all over 2a is the x, right?
Yeah,
And how do we find the y?
by plugging it in.
Plugging the x into the function. Y-intercept. What's the formula you guys figured out for that one? Josh.
Parentheses 0, comma y.
Uh-huh. And Neve, how do we find the y? By putting x equals 0 in. So to answer the questions, aka to work out the warm-up. Jay, put the paper down. Thank you. We need to go ahead and ask ourselves the question, who is A and who is B? And I think, Ian, this was your question. Now is the right time to ask it, but let's ask it as a class. Who is A, who is B, who is C? As we look at this quadratic, kiddos, A is the number in front of what? X squared. And what number is in front of x squared? No. Negative 1. B is the number in front of x, and that number is just in focus? Negative 8. C is the number, well, that doesn't have an x,
7.
which is going to be our 7.
Wait, I'm confused. Why is it negative 1? It's supposed to be 1.
There's a negative.
Because there's a negative.
There's
Oh,
a
I thought you were
negative.
plugging into the x. I thought because there's 2 negatives.
That's how you're plugging.
Johnny, go ahead and take all your stuff, Mr. Kim.
Okay.
Thank you. Okay, so as we go ahead and go to plugging in, 4x equals, kiddos, what do we have?
So, negative 8 over.
Well, we need a negative and then negative 8. Justin, I think you just did that step quick. I just want to show people what it is. Then what do we have? What's 2 and a? Yeah, plug in that a, which is negative 1. So then we have negative times a negative to the 8 is a positive 8 over 2 times a negative 1 is a
Negative 2.
8 over negative 2, what is the
Negative
x?
4.
So how would I answer the axis of symmetry? Go to negative 4 and I make my straight line, right?
Negative.
X equals negative 4 is my axis of symmetry. Or I think, Jordan, you were the one that said AOS is fine. to shorten it.
So you have
You
to
sure?
just even for just for the first step, or get the.
Oh, I started graphing it because if you notice, Angel, I ran out of room. So I just wanted to write it nicely in the graph.
Okay.
Now the vertex. What do we know right away? Who is this? Yeah, it's the x from above. So let's go ahead and put in -4.
Sub.
How do we know that? We plug it in,
Yeah.
right? Now how do I find the y?
You plug in
K of x is just a snazzy name for y. So y equals negative somebody squared, we'll plug him in, minus 8 times somebody plus 7. Remember, I'm putting my parentheses around the x.
Wouldn't it be -8? Oh,
You're
you're
talking about.
Now, who are we going to plug in those spots?
-4.
So I just went parentheses.
I'm showing you where the x is because the x needs to go out and the number needs to come in. The x needs to go out and the number needs to come in. Now guys, I'm not going to go through all of PEMDAS all over again. Some of you have gotten in the habit of how to do PEMDAS. Let's just say -4 squared, I'm just going to go in the right order, okay? What's -4 squared? Positive 16. And what's a positive 16 times a negative?
A negative 16.
What's, PEMDAS then says multiply. What's -8
32.
times -4?
Plus 32.
Positive 32. And then I have plus 7.
And then you add all
You
the.
can do it in any order. I kind of like 32 plus 7 better because I think I can do it faster. 39 minus 16 would end up being 23. Now what is that again?
Bless you.
Now what do I do with this?
Blessed.
Thank you for that, but now it's focus. I have -4 and then, ooh, what do I need to have as my y value?
23.
23. Well, maybe these units aren't good ones to use. Maybe what should I use instead of 2, 4, 6, 8, and 10 if I have to go to 23?
5. Well, you could go by 5.
We could do 5. So let's go ahead and change this then to 5, 10, 15, 20 on the y-axis. So that'd be -5, -10, -15, -20. Okay. So now 23 would be about here, right?
Yeah.
Yeah.
But you still put 30.
So we go -4, 23. Yeah, Angel, thanks for noticing. I didn't realize there was one more number. So negative. Actually, I think it'd be 25, wouldn't it?
Yeah.
Yeah.
Whoops, my bad.
All right, so I have my 23 marked as my vertex. Can you guys tell, is this concave up or concave down? It's not asking, but I'm asking. Why concave down? There's a negative, like a frown. If you're a negative person, it's concave down. So we know it's concave down, right? But how do we know how wide or how narrow to make it?
The y is out.
Let's go find the y-intercept.
Let's do it. Plug
So-
0 in.
I'm going to take my function. You guys told me to plug 0 in, and I can do that. Let me set up my function.
Oh, I'm so
Yeah.
So I put parentheses around each of my x's, and now let's plug in
Settle.
0.
Oh, it's off again.
Who's 0 squared? Rob?
0.
What happens to this guy? 0. What happens to this guy?
Settle.
0. Who's left over?
7.
So where am I going to hit on the y-axis?
You're gonna go,
I have a question, Ms. G.
At 7.
and then you're gonna.
Okay, pause, Josh. Hold on 1 second. Rob.
Vertex, you have -16 plus 32 plus 7. Would you combine 32 and 7 and then just take it?
That's what I did, because in my mind, you're technically supposed to add, subtract from left to right, but in my mind, the addition is
No.
fast, so I did 39
No,
minus
negative
16.
Oh, 30.
Minus 16, yeah.
Get off me.
Or if you want, you could do -16 plus 32 is
Either way.
16. 16 plus 7 is 23. Either way works. Caleb.
Wait, so it's like, for like the C, since it's 7, it's like a faster method, like, oh, you know, the wire is going to be,
It's going to be the last number. So if you use that trick and can get there fast, that's great.
yeah.
That's great. Now guys, hold on though. I only have 2 points. And 2 points are great for making a line, but it's not good for a parabola. Josh, go ahead. How do I finish?
You have to, since you went over, that, however many.
Yeah, however many boxes. Which from the line, how many boxes
4.
was that?
Wait, 2.
What am I going to go on the other side?
Oh, I thought you were saying numbers. Okay.
Oh, no, it's a,
Whoa!
I'm telling you, smartboard just goes crazy after
You
a
sound very smart. That's a good line, though.
Yeah, it is. Just in the wrong place.
Ah.
I'm gonna go 2 boxes over this way because of symmetry, right? Like a butterfly. What's on one side will copy on the other. And how do I finish my parabola?
And then that's how you know how narrow or wide it is.
Now, kiddos, one other question that was in homework last night was last time. One other question that was in homework last night: is it a max or is it a min?
Oh, that was hard.
Why?
Because it's that max.
It's the height. It's the highest, right?
Oh.
Now, how would we answer that question though?
Well, actually,
Yeah, up a mountain, the top.
Max and like value.
They ask us to fill in a blank.
Plug in that.
max value of the bird.
You can plug in, but
It's the vertex.
it's the vertex, but I don't want the x of the vertex. Do you remember what the answer is?
Why?
I want the y of the vertex. What is the y of the vertex?
Okay. Yeah.
Okay, stop judging. He's trying. Coming back. I don't have to. Coming back. So whenever you answer max or min, you gotta look at the picture, think of the concavity. Maximum is because the vertex is at the highest. What do I answer for where it is? How high is it? 23, where the vertex is. So I answer the y value of the vertex. Kiddos, that was homework last night. The first half of homework were making these. The last couple, I think, of homework were answering max or min and finding the y value of the vertex.
For like, we make like the arc or whatever.
Uh-huh.
There,
Wait, help! What's the U shape of a quadratic function called?
Parabola.
Parabola. Okay, when we make the parabola.
You have to go all the way down to the bottom. Or can you?
You can draw little arrows to say it keeps going. Okay, stop. Angel, just draw little arrows to show me it keeps going. You can keep going yourself if you want, or just draw the little arrows to keep going. Okay? Kaylee, Jay, and Dylan. Calm it down. Jay asked you why you were doing something. I just assumed you did something. Okay, let's go ahead and get out our homework and check our evens. We only have not that many, I don't think.
They'll look confused on it.
Kiddos, real quick, if you're not quite ready to turn in homework today, do I give you guys extra options?
Yes, after school.
I say you can turn it in after school, and if you want to even come ask me questions during lunch or after school, we can do that as well. Your homework that's due today, 44. Can you guys read off the problems real fast for me?
13 through 17, 21, 22, and 27.
Okay.
27?
Yeah, 27.
All right, here we go.
That was just
I
22.
think that was the maximum.
It says 22. There's
Okay.
21.
Read your math.
There's no 27.
Whenever you get the data card, I took a picture and I saw 27 on there.
Was that in school?
Sorry.
I was looking there.
Let's go ahead and check the evens. I'll only be on 14 and 16 for a couple more seconds. Dylan, go ahead, Ben.
May I use the restroom after?
At least you asked for that problem.
Do you have your homework to check, buddy?
Yeah.
No.
After we go-
Oh, if you do, then yeah. If you don't, then go ahead and go now.
Okay.
I had a question.
Honesty is the best policy, buddy.
I got lost on.
Alright, so number 14.
Oh, snap.
Let me know that real fast because it doesn't write all the answers.
Yeah, I do.
The axis of symmetry, what'd you guys get? X equals? -3. Good. The vertex would be -3. What'd you get as your y value? -23.
I did the y-intercept. Were you supposed to do that or no?
So, axis of symmetry, x equals -3. Vertex is -3, -23. The y-intercept, I believe, ends up being something like 12, 13. Now the question is, how could you get the graph without using your clues? Didn't our notes say the graph using clues? What's the only other acceptable way to get a graph? Table. So if you don't have a table and if you don't have your clues, I have to say you didn't show any work. I'm not giving you full credit. Follow what we do in notes. Now kiddos, all parabolas. Domain, we talked about it actually back in section 8.1.2. How left, how right, domain is x values. How left, how right will every parabola go? What's the domain? Forever left, forever right, all their numbers. Range, how low, how high. Number 14, how low does it go? Just negative 23, that's the minimum value, so we can have our range be y is greater than or equal to the minimum, negative 23. For number 16, why is it y less than or equal to 13? How?
Because it's the max.
Yeah, it's the maximum, which means the y values have to go below that, right? So below, less than or equal to 13, above, greater than or equal to negative 23. Let's keep on going real quick. Number 22 was the only other even you guys had. The maximum value is 12. That is the y value of the vertex.
I need number 17.
17's in the back of the book, so if you want
I
to
know,
check it really
but
quickly, you may.
I
Oh,
wouldn't
questions. Thank you, Josh.
Yeah.
Oh,
Alright,
yeah,
goodness.
17.
Any other questions
Wait, how do
besides
you get 12? Wait, where do you get 12?
Because you plugged.
Oh, and for 27, yeah. Wait, did you already ask them?
have. No, I answered
Oh,
You guys told me 27 wasn't on homework.
No, it was.
It was.
It was. I took. I have a picture of it.
That 21 was on homework.
Jay had a question on number 22 real quick. Kiddos, what was the quadratic for 22? Y equals, or f of x or g of x?
Negative 5x plus 10x plus 7.
I wrote the vertex.
Yeah, what is the vertex?
I probably got it wrong. I put negative 2 over 5, 3.2. I probably did it so wrong.
Oh.
Wait. Oh, I forgot to multiply
Then you
by
plug
2.
that into
Then you have to
y.
plug in to get the y value for the maximum value, right? So y equals negative 5 times 1 squared plus 10 times 1.
Wow. 12, yeah.
Negative 5 plus 12.
So
112, right? Like as the vertex, you write it 112. Or you only have to write the
Oh,
1.
I wrote 7. Sorry.
Whoa.
So do you have to write?
Pause. Jay's asking what part we asked. Jordan, I see that question. Give me 1 second. Yesterday, in our notes, kiddos, what did we say we were supposed to write for the min and max?
Oh, why?
Oh,
Sorry. Oh, wait.
So do we need the x and the y?
Ooh.
All we need is the y
Nope.
value, right? Which is why, not a play on words, but you can take the pun if you want it. The pun would be, which is why I only wrote down what for the answer yesterday. So what do we have to use when we do our homework? Our notes.
Are there symbols used for tell whether it's like a minimum or maximum, or do they have to always write it out?
You do min and max,
Okay, but you get that without writing it, right?
because it's an abbreviation. Jordan, what's your question, kiddo? That's what Jay was just asking. That is where it happens, but when they ask for the min or max, they're saying how high is the highest, how low is the lowest, just the y. You don't even have to write y equals, you can just give me the max is 12. Does that make sense? Yeah. Does that make sense? Okay. Josh, you said you had a question. What was the problem with the question?
Number 17.
Okay. Any other questions from homework? Going once? Going twice?
21. Twice.
27.
Yeah, honestly, I did.
21.
Alright, remember, we'll come back to homework questions as soon as we cover section 8.6. Here we go. Notes open, then we'll come right back to homework.
Okay, are we baseball?
We're always in baseball.
Alright, kiddos. We did the warm-up where we reviewed the axis of symmetry, the vertex, and the y-intercept. But now we have to get into section 8.6 and what it is all about. Let me give you guys a couple moments. It is a big old summary of how these three types of functions and their three equations and their three graphs, how they look the same and how they look different. So, Diego, right now it's time for both of you just to be writing word for word in your notes.
Would you like us to write?
Yep, draw the sketches, because the whole point of section 8.6 is condensed down into these three pieces. Linear, what does equation looks like, what does graph looks like. Exponential, what does equation looks like, what does graph looks like. And quadratic, what does equation and its graph looks like.
Oh, so we're doing 3 and 1. Okay.
Yeah, we're comparing the three that we've already covered. We've covered lines, we've covered exponential, we've covered quadratic now. we're just going to go ahead and see, can we pick out from given information what type it is from either equations or points or graphs? Jordan, go ahead. Probably not this one. Algebra 2. She's saying x cubed. Yeah. With factoring, we saw x cubed a little bit, but we haven't done graphs of x cubed. Josh, you ready to get back to notes?
Sorry, yeah, my finger was moving.
Do you need a Band-Aid or an alcohol wipe? All right, here we go.
Oh, is this notes?
Yeah, we're back in notes. We'll come back to homework questions as soon as we finish these examples.
Mr. tell me lessons for the notes that we had to have again.
8-1 to 8-3 and 8-6. That means 4 total. 8-1,
20 points.
8-2, 8-3, and 8-6. 20 points for notes on Thursday. Good.
How can you skip sections?
There's a lot to cover in our book, and so we're just going to kind of hit the most important things from here on out. Does that make sense? Chapter 9 is super important. Chapter 8, half of it was pretty important. And plus, I already kind of know, or I also kind of know what Jordan's been asking me, like, hey, when are we seeing this? I know some of this you're going to talk about in Algebra 2 or in geometry, so I kind of saved some of it for later. That's why we're skipping some stuff. I'm writing a quick email to the office. You guys keep writing word for word and get those sketches down. The words, the equations, and the sketches. The words, the equations, and the sketches.
What's the hardest chapter that we're going to learn?
Probably, I would say the factoring chapter was really hard. Factoring.
The last one?
Mm-hmm.
Oh, yeah.
Factoring. And then also, chapter 9 is going to be difficult at times. But I honestly think factoring is worse.
Once we get to the test.
Chapter 9 is over solving quadratics, completing the square, things like that.
Expo. Will you ask us on the test, like, which graph is like exponential, which graph is linear, and which graph is quadratic?
I could ask you that.
For like bonus or just an actual question?
Probably an actual question.
Okay.
So kiddos, if you notice way down here, this is the type of question you might see. And I haven't given the pieces of information quite yet, because I want you guys to see the first 3 first. But the directions might be identify the following as linear, exponential, or quadratic. Now the book technically has problems where there are tables. And I think I might have given you one of those table problems. Is it number 36 maybe? It might be in your chapter review. I gave you a table problem. So we'll talk about tables, but the most important thing is, can you match up linear to be the description of an equation that looks like this? Y equals mx plus b. Go ahead and stand in the back by the window so we can keep on taking. So linear describes y equals mx plus b. X is to the first power. And, yes please. And its graph is going to follow a straight line, right? It's linear. We got it. Now, exponential. Can you match the word or the adjective? You guys know adjective means describe, right?
Yes.
Can you match the adjective exponential to an equation or a function that looks like, did you guys figure out? X is in the exponent. Is that highlighter a little bit too dark?
Yeah.
X is in the exponent for that equation. And you guys remember this is the swoop, there it is, one.
Oh, swoop!
Yeah, right? Now, does he have to swoop up? Can he swoop down?
Yep.
But here's the long story short. What's the difference between this one and that one? I mean, the equations are way different.
This one has one of them has a concave.
Can you
Yeah, they actually, ironically, they actually both have concavity. That's kind of weird for you guys to think about, I know.
One's like a smiley face concavity, one's a big smiley.
This one's a half smiley, this is a full smiley, and that's the difference.
A smirk. That's the face makes smirk.
Exponential, you can call it a smirk. It's concave up, but it only has half of the concavity, right? It only goes up. Doesn't this one decrease, go down, and then go up?
Yes.
So the difference between quadratic and exponential. Exponential, swoop, there it is, it just swoops up. Or it just swoops down. It doesn't do both. Quadratic, the equation looks way different, has an x squared in it. And it goes down and up. With the U shape, the parabola, right? So, if I give you guys the following points in these three graphs, okay? I want you guys to go ahead and try to describe them with one of the adjectives, linear, exponential, or quadratic,
Oh dear.
based on what they look like.
So you're gonna draw the thing?
So draw with me, because these are your three examples. Ready? I want you guys to go ahead and draw this one. So right now we're literally just drawing points.
Oh.
Okay.
It could, except it's not an option.
Why you
But
gonna
good seeing that. All right. Take a second.
Oh, it's just,
I know
it
it's
just
a
keeps
habit.
coming up on my
I know
hand.
it's a habit. I just really don't want to take it as being disrespectful, right? Okay, do you guys have your points written down? Now try to pick
Almost.
one adjective for each one. Which one adjective seems to fit? And write it down underneath the graph. If you had to choose one, linear, exponential, or quadratic.
For A?
For A, choose one, write it below. For B, choose one, write it below. And for C, choose one, write it below.
Oh.
See why I think 8-6 might go fast?
Heck yeah.
So you just pretty much identifying?
Yeah.
That's really easy.
You're saying what's the pattern. Now this is with a graph. Graphs are kind of the easiest. We'll see one more type of example on the next page. But question. Who is pretty confident they know what A's adjective is?
Me.
Rob, what do you think?
Linear.
You guys agree?
Yes.
I do too.
Agree.
Because what kind of graph could connect them all? A line.
Right.
Line.
Angel, what do you think? For
Quadratic.
Got it.
Out of boy.
Out of bed. Oh, man.
What could connect it? A U shape. It's the only one out of linear, exponential, and quadratic. It's the only one that could connect those three. Ian, what do you think for C? You got it. Swoop, there it is.
Yeah.
Now wait, is it swooping up or swooping down?
It's swooping down.
But does it matter?
Down like a frown smirk.
Yeah, but it's only like a happy brown smirk. There you go.
I don't know how to do that.
So, how many of you guys are like, hey, I think if I just kind of say those three words, I got it.
Yeah.
Hopefully. But let's go ahead and say, what if we don't have a graph? Can we still get it?
Yes.
Yeah. Whoa, what is that? No, no.
Okay, it's okay. It's okay.
This was easy, dude.
Calm it down.
Well,
Kiddos.
so many numbers.
What have they given us instead? Not a graph.
Oh, no, I see it.
Points.
Just wrong.
What can we, just draw it out.
Oh.
If you can draw the points, maybe it'll be as easy as the other examples. So everybody, right now, number one, I want you guys to
Easy
make
peasy
yourselves a
lemon
little graph.
Oh my god.
That was scary.
If we look at the numbers, I think we really only need like what, to 5, maybe?
Linear.
It was lit.
Hey. Try 1 through 3. 1, 2, and 3 on your own, and
Do you want
let's
us?
see.
Do you want us to write like the full problem for one?
It's up to you. You can just graph the points if you want. Just be very careful when you graph it. So instead of writing,
Yeah, I know, but the graph that came out.
oh, did you already get it?
Yeah.
-1, 5.
I see you.
Okay, I got him. You put little check marks. 2, -1. Got that. 0, -1.
Okay, sometimes I already see it.
Oh, is this gonna be homework?
3, 5.
Can you not?
1, 2, 3.
Yeah. Right.
Hush my
What is that?
1, -3. What on earth? Does anybody have any idea what this is?
Oh, yeah.
You see it?
Oh, it's a.
Yeah.
I hate you.
Quadratic.
The U is the only one that can connect. It's our quadratic.
So you have to have
Wait, I
like,
think that's 32 is way out there.
you have to have the little arc at the bottom, right? Instead of like being like straight, I could be like arcs.
Yeah. Angel, if you haven't yet, start graphing number 2.
Oh, okay.
Yeah.
Can you tell by number 2 because of what the numbers are?
Yeah, just have a reason as to why. Like if you were on a test, like on Thursday, if you saw that one, be like, oh my goodness, the jump is huge. So you can like show that jump and say the jump is getting bigger exponentially.
Yeah, because then also I know
Big
like,
time.
wait, I thought it never touched the 0.
But remember how the swoop can be shifted down? If it's shifted down, it might shift to where it hits the 0, but it doesn't hit some other line that's getting closer to it. So the shift might make it, might make it hover over another line. Kiddos in the front, if you're like, hey, I think I got this, head on to the back. If you don't have homework questions, my A and B kids from the last test. The rest of you guys, let's just finish up these examples. From my kids in
Where you going?
Jay, move back quietly or else not at all.
Not at all.
Gotta catch up.
Alright, people in the back, keep it quiet. Here we go. Did you guys already start graphing -1, 2? -2, +8? 1, 2, 3, 4, 5.
You have to grab all of them?
Yeah.
Oh,
Until you can see a pattern, Dylan. Does that make
okay,
sense?
yeah.
So like if we
So
can
it's
see
going
what
up or down?
Yeah.
Can you have an estimated guess?
-3. Oh my goodness, I'm gonna estimate guess this one, Angel, because isn't he just way up there somewhere?
Yep. Oh, that's what it is.
Now wait. 0 is 1/2. Oh, that doesn't look like linear though. Isn't it kind of swooping?
Oh, yeah.
Okay, focus on it. 0 is 1/2. What else am I missing? 1 is 1/8. How did I graph 1/8? That's like put it way down here somewhere.
Very low.
Can I connect this with a line?
No.
No. What about those two guys? Can I connect this with a parabola?
Yes.
No. They don't show me anything going up. So Angel, look.
A little frown.
Which one swoops down?
This one's called.
Good. That one's called exponential. Oh, you're trying to explain? Okay. It doesn't go back up. It's not a parabola. It just keeps on going down. It has to be exponential. Now, on number 3, kiddos, maybe you're like, I'm not exactly sure. We could guess, but let's not guess. Let's make sure. On the test, maybe I'll have 2 quadratics or 2 exponentials. You never
Would
know.
you have problems with the row like this?
Yeah, because it's section 8.6.
That'd be easy. Never mind, that'd be pretty hard.
You just have to study the words, right?
That'd be very, very difficult.
Just you have to
You
memorize.
shouldn't put that on the test.
You
Yeah.
think that I will?
Don't pass the test like this, please.
Make the whole test like this.
Hey guys, what's it looking like? If I keep on going?
Linear. Nice and straight.
Yeah, nice and straight.
Test.
Now wait. This is just section 8 or section 8.6. But kiddos, we can get 8.6.
Yeah, 8.6 is
We
nice.
just have to study these 3 words. Let's see if we know what they look like.
Wait, is this all 8.6? That's an amazing section.
That's it.
Why can't algebra be like this?
Yeah.
Well, it is
Just
partially
guessing what it
patterns.
is.
It's partially patterns, but we have to know how to use equations too. So graphs and points, that's part of it, but we have to know these equations.
Give it to me.
Alright, we're gonna go over the homework questions that were asked earlier real quick, but you guys go ahead and get a picture. Jay. You have like 2 minutes. We'll just wait until the back. Alright, you guys have the homework written down or you have a picture of it? It's also on the backboard. It's also on the backboard. Oh, you don't have your book. Alright, let's go see those homework questions. What was going on? What got tricky?
Are we trying this homework?
Yeah, as soon as we go over 17 and 27. So people think it's hard. People in the back, if you had 17, Haley, Josh, if you had 17 or 27 as questions, you might want to double check. You know how to do it right here. Alright, cool kids, let's go see the homework.
She lied.
I can see better.
Alright, number 17. What was going on, kiddos?
Jay.
Alright. Question, can anyone tell me why? Ian, you have a picture of homework yet?
Yeah.
Alright, very quick, put your phone down. Good. Alright, why would someone not like 17? I totally agree. Why would someone
Fraction.
Because the fraction.
The fraction.
Can I go ahead and go to the board and just do this old fashioned? Is
Yeah.
that okay? So let me go ahead and pause
I like
this.
the old fashioned.